Okay, it's 1:06. Should we give it a moment or two more? See if a few more people join us. We've got 11 people here. Let's give it a moment or two. Okay, well maybe let's you happy to get started, Kate? So I'll just briefly say hello to everybody this evening. Welcome and thanks, Kate, for agreeing to share some thoughts on the water quality issue. At any stage, people, I think just chip in and ask questions. You can either type something in the chat function or raise your hand or just raise your voice and chip in, and we'll keep it pretty informal. So Kate, over to you.
Thanks very much, and thanks for the invitation to speak today. I just as a brief introduction for those of you who don't know me, I haven't checked who's in the room, but I'm a freshwater ecologist. I started out working in rivers, but moved quite swiftly into wetlands. But basically, yeah, anything fresh, anything inland from the estuary is my area of interest. And I am based in Scarborough, of course, been here for about 20 years. And yeah, so just as an introduction, for those of you who haven't read the document that we sent around, I'm part of one of the task teams within the Scarborough Village Association, looking at water quality issues in the village and around, because we also now probably going to include Misty Cliffs. So one of the little projects I undertook was to find some of the City of Cape Town data, and the water chemistry data for two sites that are regularly sampled in Scarborough, being the Lower Shusters River and what's always been known as the Pound Canal, which is actually a stormwater canal, and we'll have a look at a map just now. And basically the idea was to do some very, very preliminary analysis of the results, to be able to kind of present some thoughts on what's happening over a 20-year period, which is the data that we have available. And the whole idea was kind of specifically around wastewater and wastewater treatment, to see what the impact is that we are having on our immediate freshwater environment. So that was kind of the aim. And what I'm going to present today are just some of the main kind of trends that I came across in the data. So just to emphasize, then, it's not our data, it's the City of Cape Town's data, but the analyses are mine. Some of them are a little bit dodgy, and I'll talk about those and why they are dodgy. But I've done some broad brush analysis, which is to show some of the thoughts. So yeah, let's dive in. Just to show you where the two sites are. This is an aerial photograph of Scarborough up in the top left there. This is a map that I've actually taken off Cape Farm Mapper, and I'll actually share that website address with you, because it's a really, really useful website for those of you who want to go and look at the rivers and the wetlands around Scarborough. It's a really useful source of information. So basically the two sites are, one is on the Lower Shusters River. It's called SCH02 in the City of Cape Town database. And then another site is Pound Canal, as I mentioned, SCH04. I'm just putting the numbers up there because the data that we're going to look at do relate to those specific site numbers. And just to show you where they sit in Scarborough. The one on the Lower Shusters River is basically, as far as I know, I think it's just above or at the entrance into Schuster's Kraal, into the picnic site there. And the Pound Canal, I'm actually not 100% sure where they sample, but I think it's quite close to the toilet block there. And the two sites kind of represent quite different parts of Scarborough. The Lower Shisters River obviously receives water that's flowing out of probably the southern portion of the village, but it is, and this is why I've shown you quite a broad photograph of the area, because it's quite clear from here which rivers actually feed into the Shisters. So it's not just what's coming out of Scarborough, but it's also draining up on Red Hill. It's draining the informal settlement there. It's draining the farms in that area also. And it's also draining Buscliff. I'm not sure if you can see my arrow, but the stream that comes through Buscliff comes in there. So it's kind of, it's a mix of quite impacted river reaches and quite pristine. So obviously the one that's coming from Buscliff is quite a pristine source coming into the Shisters, and then the stream that comes past sort of Massey and the Cape Farmhouse is receiving runoff from quite a large portion of the catchment that's been quite heavily transformed. So if you know, those of you who drive along the road up to Red Hill during the winter months and you see that water rushing off the slopes there, rushing along the road, rushing over the road, it's carrying with it quite a lot of sediment and probably other organic pollutants coming from the Massey area, and then all the soakaways and septic tanks on its route into Scarborough. So those are the two sites, and the data that we have, as I said, is for 20 years worth of data, 20 years worth of data. There's that Cape Farm Mapper website. I'm not sure if we get to share the slides later, John, with everyone, but the website will be on there. Just another view of Scarborough and those two sites and the little streams that feed into the ocean from Scarborough, just to give you another perspective on the area and where the sites are. This is a picture that was taken from an aircraft just after the 2008 fire. So quite a nice photograph because it really shows the boundaries of Scarborough and how the southern portion is feeding into Shisters and the northern and middle feeding into the Pound Canal, and probably also that little stream that heads off just before Muscle Beach or North Beach, whichever you choose to call it. So I looked at just a few parameters. I looked at quite a few parameters, but chose to present the data on only 3. And because those are probably of major interest to people in the village and also from an ecological perspective. So E. coli is an obvious one. Those are the fecal bacteria, which affect us immediately because they can make us quite ill. And people swimming in, certainly the lower Shisters, have always been very interested to know what the E. coli levels. I also looked at nitrogen and phosphorus. Phosphorus, specifically the soluble phosphorus, and nitrogen, I looked at total nitrogen, but also the soluble versions, nitrates and nitrites. Those last two are collectively known as nutrients because they are nutrients for plant growth. And where there's an imbalance of those two or an excess of those two, you tend to get excess or excessive growth of vegetation, which might not be a problem if the excess is not too great, but when it becomes a very high level of nutrients, you get things like typha, the bulrush, growing profusely, as we see at the bottom of the Shisters, and other reeds and weeds. So I've put another website on there, which you don't need to copy down because when we share the slides, you'll get it, and we can also email it around. But just to have it up there, the data that I'm showing you are actually now freely available. I don't know if any of you saw there was a few articles online where it was reported on that the City of Cape Town has now appointed a committee. I can't actually remember what it's called, but it's a water quality committee that is helping the city in engaging with water quality issues and how to focus on how to improve the water quality, specifically in rivers and wetlands, so the natural environment. And that website gives you access to all the sites. I think it's over 100 sites. There's a KML file, so you can see exactly where those sites are, and you can access the data. Unfortunately, only it seems to be 2017 on. I was lucky enough to get the data going back to 2001 because I know who to speak to. So let's look at the data. I must kick off. We need to stop for questions yet. I'm not looking at any raised hands.
There aren't any. I'll let you know if any come up, but if anybody wants to chip in, just raise your hand or raise your voice. Go.
Yeah.
Thanks.
So the E. coli, as I said, was a good place to start because people are specifically interested in that from a health perspective. So as we all know, it's a fecal bacterium. There are other fecal bacteria, but this is the one that we're particularly interested in. It comes from sewage. It actually comes from the stomachs of any warm-blooded animals, and it can make you ill. It doesn't. What a lot of people don't realize is that you taking a few bacteria in is not necessarily going to make you ill, especially if you've got a good immune system. So you do need to, in some cases, if you're a very healthy person, need to swallow quite a bit of it before you become ill. So, I mean, the water that we swim in all the time, the sea, rivers, there's always a background level of E. coli, and it can be up to 100 bacteria in 100 milliliters, which is how we measure it, and it won't make you ill. It's quite interesting. I don't know if the city still does it, but they used to report on water quality in our flays and rivers in terms of how many mouthfuls of water you needed to swallow in order to become ill in a water body. So for instance, the stunt flare, I think, was you needed to swallow 0.000 something of a mouthful to become ill, whereas more healthier systems, the Schusters River, for instance, was always one that where you needed to swallow thousands of mouthfuls to become ill. So that was their measure of the health of these systems. What I've done, and I've done this for all three parameters, is I've done, as I said, a very broad brush analysis of the data to look at when in the year are these variables increasing and when are they decreasing. So what is the annual pattern or the seasonal pattern that we're seeing in these parameters? And then the second graph that I'll put up just now is looking at a trend over the 20 years. So a very broad average of the variable over a number of years. So firstly, looking at the monthly data. So this is about 20 years of data averaged for each month over that entire period. So you can see very broad patterns here where the Pound Canal, which is the orange line, and it's always going to be orange in the graphs, and the schisters, lower schisters, is always going to be blue. You can see that the E. coli and the Pound Canal kind of jumps up and down. It's got a couple of peaks in March, so kind of late summer. There's a peak in E. coli, quite high. There's another peak in June, and then again in kind of, in spring. Whereas the Schusters River, the lower Schusters River, has a very clear sort of seasonal pattern of increasing through summer into late summer, and then decreasing into winter, and then heading towards December, it starts picking up again. So a very clear seasonal pattern, peaking in kind of, in autumn, basically around about now. And we'll have just a little bit of a chat about what that means just now. And then looking at E. coli, again, as I said, over the long term, so taking 20 years worth of data, averaging it over the whole year. So you're flattening out all those peaks and troughs throughout the year to give an average for each year. And there you can see some patterns as well, where the dotted line is showing you a long-term trend for both sites. And you can see for the Pound Canal, again in orange, your long-term trend is a very slight decrease over time, whereas for the lower schisters, the blue dashed line, there's a very slight increase over time. But the peaks that you're seeing in the Pound Canal are always much higher than the peaks that you see in the schisters. Although worryingly, there are still quite high peaks in the schisters as well. And I just wanted to show you, zooming in a little bit, which to illustrate my point about the trend information being a little bit shaky information to look at, because you're losing all your ups and your downs, you're averaging it out. It's a real sort of broad brush look. I wanted to look at the last 5 years worth of data for E. coli and look at this against the city's kind of threshold. What is, are these levels in putting us in danger at all when we're swimming in the river? And I looked first at, so this is just 5 years worth of data, so from 2017 to the present. Firstly, what I wanted to point out is the trends actually look quite different. So the orange dashed line, again, that's the trend for the Pound Canal, is now increasing over time. And the one for the lower schisters is staying pretty steady. So even though over a long term, it looks like the Pound Canal E. coli is coming down, in the short term, the last 5 years, it's actually going up. So we must just be aware that those long-term trends can actually hide quite a bit of information. So we need to be very careful about looking at those kind of trends. Now, what I put on here is a red line here, which is at 4,000 E. coli units or bacteria per 100 mils. And that's a level that the city looks at as being acceptable. So everything below 4,000 bacteria per 100 mils is an acceptable limit when it comes to contact with the water. And that level is between the orange, looking at the table at the top here, between the orange and the red. So you're going from a tolerable risk to an unacceptable risk if you're going over 4,000. So I've just put that line on here for us to see. We can see then that at some points the schisters exceeds it, and so does the Pound. This massive peak here, which I think is in about July and August 2021, is a huge peak in E. coli, and it looks like the city actually came out specifically to take a few more samples in 2021 to maybe look at why this was. I'm not sure of the reasons behind it, but quite a, it's a massive peak. Just going back to this table at the top right, there are these different levels. So let's just have a look at those. The city provides in blue here. That's a target for maximum acceptable risk for full contact recreation. So that's swimming. That's where you're putting your head under the water. The next bar is green, which is an acceptable risk for intermediate contact. And intermediate contact is where you're not swimming in the water, but you're still engaging with it, but you're canoeing, you're sailing, you're on top of the water. Surfing would be seen as full contact, not intermediate contact. So you can see there that as you go, as the E. coli levels increase, you're going from the target level, which is 400 to 2,500 in green, and so it goes. The red is going over into an unacceptable risk. And there are, it's just very worrying that in the schisters and the Pound, we do go into that unacceptable risk every now and then. And then zooming in again on the schisters only, the lower schisters, because I know people worry about that quite a bit. And again, looking at the shorter time frame, the last 5 years worth of data, I put on there in red that acceptable limit for intermediate contact, and a green line at the bottom, which is the acceptable limit for full contact. So that's swimming. And you can see there that the schisters, the lower schisters, is remaining for most of the time. It's on or below that green line, so the swimming limit, as I've called it, which is good. But you can see there that there are at times peaks at certain times of the year that are going above the green line and also above the red line. So that we do need to worry about. And you can see that there's a bit of a pattern emerging, where you've got a peak. If we look at 2019 and 2020 going into 21, there's a peak in March and a peak in December. I haven't looked back to see in previous years whether that follows through in other years, but it kind of makes sense where you've got a flushing of E. coli, possibly with the early rains into the schisters, and then in December, as things are heating up and concentrating, again you've got a peak in E. coli in December. The February-June peaks in 2017 to 2018 is a little bit out of that pattern, but those were drought years. It might have had an impact on what was happening. I'm not too sure. So yeah, we in some ways we can be quite glad that the river is remaining at an acceptable limit for swimming for most of the year, but we do need to be concerned that there are these peaks, and also to know which times of the year it's safe to swim in the river. So what are our key messages for E. coli? In the Schisters River, the dilution of E. coli levels does occur during wet winter months, so the river is actually diluting it. So you would need to swallow a whole lot more water to become ill. But as the river drops, E. coli levels are becoming more concentrated. And over the long term for the Schisters River, the E. coli concentrations do seem to be gradually increasing, but over the past 5 years have decreased. So I would think that over the long term, you probably are getting trends that are going up and down. So one would need to look at that a little bit more closely. Levels are generally below the target for acceptable risk for full contact, but in summer there are unacceptably high peaks, which we need to be very aware of and very careful of. In the Pound Canal, levels are frequently within the acceptable range for intermediate contact, but there are also unacceptable increases in March and June, which is when possibly early and then midwinter rains are flushing E. coli from the soils in Scarborough into the canal via the stormwater at this time. And what I think I might be wrong, but it is possible that the Pound Canal, which, if you remember, is accepting seepage from basically the northern part of the village, that the Pound Canal is possibly more influenced by what's happening in the soils in Scarborough. So what's being retained in gardens, what's coming out of septic tanks, so water movement below the surface, whereas the Schisters River is far more heavily influenced by surface flow impacts in the catchment. So water coming in from the various little streams that we saw earlier are going to have a major impact on what's happening in the Schisters. Does anyone want to pop in with questions there, or should I continue?
Hi. Do you mind if I just make an observation about the E. coli before we move on?
Yes.
Okay, so I mean, just in general, the E. coli is a marker of pollution. It's used as a marker of pollution because it's the most common bacteria in our body. Okay, and so there are few strains of E. coli, a very small number of strains of E. coli that actually cause sickness in us. Okay, why people use E. coli is because it's the most common bacteria in our body, and because it only occurs in warm-blooded creatures. It can't multiply out of the thing. So just for clarity, it's actually a marker of the pollution. It's not a direct indicator of a disease causing bacteria. There's a minority of strains which are that. It doesn't take away of using it as a marker. It's used all over the world just because the levels of other bacteria that causes disease are so much lower than this very common bacteria in our stomach. So just so people don't worry that, whoa, there's so many E. coli, I'm going to get sick from it. Most of those E. coli are symbiotic and are actually good for us. It's just a marker of the level of fecal contamination. And then just another thing is that just looking at the location of sampling in the Pound Canal, I just wonder about the situation of the beach toilets' own septic tanks in relation to the sampling site. So for me, there's always the probabilities there's extremely high, short-lived levels of E. coli might just be related to the close proximity of the beach toilets to there. So we get a sharp downfall and it spills over straight into the sampling area.
Yeah, no, it could be. And as I said, I'm not 100% sure where that sampling site is, Dave. So whether it's above or below.
Yeah, sorry, it's just observation. I'm not.
Yeah, thanks, Dave. Great. I'm going to carry on just in the interest of time, so we can get past the data and get to the questions. But my next analysis was looking at nitrogen, and which is always looked at in three sort of broad groups: the nitrates, nitrites, and ammonia. Nitrogen, as I'm sure everyone knows, is essential for plant growth. Sources of nitrates include sewage, industrial effluent, fertilizers, but it also comes very naturally from rocks and soil. So again, using the same colors and the same approach, I've looked at what's happening in each month over a 20-year period. And again, the Pound Canal shows a lot of ups and downs, way more than the Schusters. But basically, in the Schusters River, you've got total nitrogen. So I've put nitrates, nitrites, and ammonia together. Schusters River, you've got a peak in early winter, and it's at its lowest in spring. Whereas in the Pound Canal, total nitrogen increases in winter and reaches a low in late summer. So similar, but it's got a few more ups and downs. So again, yeah, Dave, maybe you're right. Maybe it's being influenced by those toilets there, but also possibly just the slight complication of that location being more influenced by what's happening in the soils rather than a flushing that's coming from the river. And then also over time, nitrogen is increasing in both the Lower Schusters River and the Pound Canal, with levels considerably lower in the Schusters. And yeah, it's increasing slightly. The levels are still sufficiently low in the Schusters not to be worried about at this point. And again, the City of Cape Town provides us with some thresholds to use to decide whether these levels are acceptable or not. I'm not going to run through it, but just in my little notes on the key messages, I do bring that in. The nitrogen is taken up by plants, so it tends to decrease in water bodies during the growth season. So you do naturally get a fluctuation happening where it's decreasing. If there weren't any other sources, it would decrease naturally going into spring and summer. And the Schusters River certainly benefits from the dense vegetation growth in and around the river and the wetland as well, whereas the Pound Canal doesn't have that benefit of a solid kind of vegetation community to take up that nitrogen. And the Pound Canal also receives whatever's flushing out of the soils without the benefit of plants to do that filtering job that would be there naturally, which might explain the slightly more up and down nature of the data in the Pound Canal. The Lower Schusters River, the nitrogen levels are always below the target for oligotrophic systems. So those are systems where nutrients are low, which is good. So it's always sitting in the blue category there for the city's water quality guidelines, which is great. So nitrogen isn't a huge worry for us in the Schusters. The whole of winter and into early summer, though, the Pound Canal is mesotrophic, so that's medium nutrient levels. Maybe not something to be too worried about, but it can, if it carries on increasing, then you're heading into eutrophic and hypertrophic conditions. But the river, or rather the canal, is still seen in terms of nitrogen to be in fair condition. So no big red flags coming from nitrogen there. Moving on to phosphorus, there's a slightly different story, which we'll come to, but just to give you a bit of information on phosphorus, it is also essential for plant growth, but should occur in much smaller quantities than nitrogen. Sources of soluble phosphates come in soaps and detergents, sewage, obviously, fertilizers, but also, as for nitrogen, it occurs naturally in soils and rocks as well. Where you have uncontrolled erosion, so possibly as we're seeing in the catchment around the sort of Red Hill area, where there's quite a bit of erosion that you can see in winter, that runoff that's coming along the road is pretty loaded with sediment, and that's also bringing quite a bit of phosphate potentially from the soils, and also whatever's sitting in the soil from washing water that's been deposited there. Then looking at the orthophosphate levels, orthophosphate is just another word for soluble phosphorus. In the Schisters River, the total phosphorus is peaking in summer, in December, with a slight increase in June, which might also be from the early rains bringing it in from the catchment. In the Pound Canal, orthophosphate is high in summer and lower in winter, as one would also expect, so quite a clear seasonal pattern there. Over the long term, looking at those averages over the 20-year period, orthophosphates again are increasing slightly in the lower schisters and decreasing slightly in the Pound Canal, but the levels in the lower Schisters River are far, far lower than in the Pound Canal. So that's quite a worry for what we're seeing in the Pound Canal, which is consistently a lot higher, except for one rather worrying peak in 2013. Again, I don't know what happened there in the lower schisters, but a massive influx of phosphorus there. There's always the chance with these outliers that it's data that's gone wrong, but because that's an average over the whole year, there must have been quite a consistent high level in that at that time. So again, our key messages, and once again, the same table from the City of Cape Town, giving us an idea of thresholds. We know when are we going from acceptable or good, fair conditions into unacceptable conditions. Phosphorus, which is the soluble phosphates, is taken up by plants and in much smaller quantities than nitrogen. And in healthy environments, nitrogen should be more than 25 times more plentiful than phosphorus. And so often in the natural environment, phosphorus is the limiting nutrient. But if it becomes available in these higher quantities, higher than normal, then plants and algae tend to flourish. And you'll get something like an algal bloom occurring in surface waters when your phosphates accumulate. Phosphates do accumulate in soils and sediments. In constructed wetlands, they've found that when you've got nutrients pumping into the constructed wetland, the nitrogen is well dealt with by the plants, but the phosphates are mostly dealt with by the soils and the sediment in the wetland rather than the plants. In the Schisters River, the phosphate levels are generally in the target range, so showing that it's in good conditions, so oligotrophic, low nutrient in winter, increasing to poor to unacceptable, however, in summer. So that seems to be an increasing trend over time. So phosphorus is, or the orthophosphates, soluble phosphorus is becoming an issue in the lower schisters. The smaller peak in June, as I said, may be due to flushing of phosphates from the soil in the catchment into the river. And then the Pound Canal, unfortunately, is always in the unacceptable range, always hypertrophic, high levels of phosphorus. So even though it's decreasing slightly over time, it's still extremely high, so still to be worried about. Just a couple of key messages overall from those three parameters. So the E. coli as an indicator, the nitrogen and the phosphorus, water quality is always far worse in the Pound Canal than in the lower Schisters River. And I've sort of discussed a little bit around that, what might be the reasons. The Schisters River benefits from having a much bigger catchment, a greater dilution factor. Looking at those long-term trends, water quality does appear to be slowly improving in the Pound Canal, but not to hide the fact that the levels that it's at are still very high, especially for phosphorus. E. coli is still high, but seem to be, and for me, this is also very worrying, is that there's this slight deterioration in the lower Schisters River. And that, yeah, could be due to a number of things, the increasing numbers of people in the village, or changing behavior in the village as well. The main concerns then are, I would say, an increase in E. coli and phosphates in the Schisters River, and the still unacceptably high levels of E. coli and both nutrients in the Pound Canal. And basically, we must learn to manage our water use and our sewage processing, and be very careful in terms of what we allow to enter into the ground through our septic tanks and soakaways. And septic tanks and soakaways that are blocked or not working must be assessed. I'm going to come back to that just now, but what I wanted to do is just quickly put in some data that we looked at some time back, which is where we collected samples from 4 boreholes. I think a lot of people have been thinking about the quality of the groundwater as well. The map I've put up there is very colorful and slightly confusing, but what I've done, again, this is from Cape Farm Mapper, and the different colors are showing us the direction that water is flowing in. And it just slightly more clearly shows you how we've got basically 2 catchments in Scarborough, which is the water that it's flowing into the Pound Canal in the northern part of the village, and in the southern part of the village, it's flowing kind of in a southwesterly direction towards the Schisters River. And on this map, we can also see the 4 locations of the boreholes, 1, 2, 3, and 4 from the 2 different catchments. And just briefly, some of the results there. I'm going to look at only one of them really, which is the fecal coliforms, which is not just the E. coli. So here we've got all the fecal coliforms put together, and they are very low. So we've still got in our groundwater really low levels of fecal coliforms, which is good. We don't need to worry too much about the iron. I highlighted it here because people are always interested to know, can they use their groundwater in their gardens or in their homes? And obviously the iron content there is an issue for your pipes and your toilets. It's not a huge issue from an ecological perspective. Nitrates are really low. pH is quite variable, but I'm not going to be distracted by that. I just wanted to really show that in terms of the E. coli being still very low in the groundwater, which is good to know. There is a slight difference where you're sampling boreholes that are shallower versus boreholes that are deeper. There is a sort of shallow, I wouldn't call it an aquifer, but there's a shallow component of the groundwater in Scarborough, which can come very close to the surface towards the end of winter. And then we've got a much deeper aquifer as well. And there's quite a bit of rock between the two. Certainly where we are in the bottom of the village, we can see that quite clearly, where the water table comes to within 3 to 2 meters of the surface. But that's really a reflection of what's coming from the surrounding catchment at quite a shallow level, and then much deeper down there's a very clean aquifer going out to sea. And then what the last little couple of slides, I wanted to just give you some thoughts on septic tanks. I'm not an expert, as you will know. I'm an ecologist. I'm not an expert on wastewater treatment, but I do have a couple of thoughts around septic tanks, and I just wanted to share those. And basically, I wanted to say that septic tanks and soakaways are a very old technology, and together they actually work extremely well when they're working well. If one of the two is not working, though, they will fail. And also when certain thresholds are met in a particular area, you will get an overload of pollutants coming into the environment. The processes that are occurring in the septic tank are anaerobic, which means they are much slower than aerobic processes or aerobic decomposition. So they will take a long time, and they'll take a long time to build up to the point within a septic tank where they are occurring effectively. In fact, just like the human body. So we are also, we're mostly water. We're also 50% bacterial cells. So we are also like small wastewater treatment plants walking around. And we, as we know, we don't often want to clear out our bacteria completely and start again, but at times it's necessary. And as long as everything's working well, then there's no problem. So if all septic tanks were operating optimally, we would be likely to see lower inputs to surface and to groundwater. And realistically, we are in a village where there's probably a majority of us have septic tanks and soakaways, and ideally we would make those work better rather than going over to much more expensive systems, which would be great ideally, but many of us can't afford. But there are many ways that we can look at to make septic tanks and soakaways more effective, and there's a whole bunch of variables. You can look at your tank size and your tank shape. If the shape has an impact on where your inlet and your outlet are in relation to each other. If they're too close to each other, then you kind of short-circuiting the whole process. So that where your inlets and your outlets are important. How is your soakaway performing? That is extremely important. I think a lot of the problems that we have with these septic tanks and soakaways, that the problem's actually lying in the soakaway because it's been blocked. Your septic tank might be working really well, but your soakaway has been blocked. Septic tanks need to be watertight. If they are either receiving water from the soil around them, then that's kind of diluting the process and filling the tank up far too quickly. If water is leaking from your septic tank out into the soil, then you've got pollutants going directly from the septic tank into the environment and bypassing your soakaway. We need to look at pump out frequency. I came across, I was interested to look myself at, you know, what is the norm, or what is the advice around pumping your tank out, and came across some interesting science which is actually really old. It's back in the 1990s, but quite a nice graph of your pump out interval versus the occupants and size of your tank. And you can see there, if you take the smaller tank, which is this line here, which is almost 4,000 liters, so actually a relatively large one in Scarborough size. If you are 2 to 3 people, you should be pumping out your tank somewhere between 15 and 20 years frequency, and so on. So the larger the tank, the less frequently you need to pump out. So coming back to the fact that this is an anaerobic system, you want to allow those bacteria, those beneficial bacteria that were spoken about in the last webinar, you want to allow those bacteria to develop sufficiently. I found a whole lot of information around the sludge versus the scum sitting in your tank. The scum sits at the top, sludge sits at the bottom. There's a delicate balance between the two. You don't want your scum going out of your outlet into your soakaway because it blocks it. These are all sort of aspects that someone going in, a company like DC24 going in and having a good look at your septic tank and to find out what's going wrong, I think it's essential to have a good look. You need to look at your occupancy. As you see in that graph, the number of people using your home is a very important factor to look at. And are you coming for holidays a couple of times a year? Are you coming out every weekend? Do you live permanently? Is your house a guest house or B&B? So the way you're using your home has a huge impact on the way the septic tank and soakaway will be working. And then the last one, a more obvious one possibly for everyone, is the products in the home. What are we using? What's going down our toilets? What's going down our sinks? And we need to be particularly aware of salts, of detergents, and of bleaches. All of these things can have a huge impact on the bacteria that are working really hard in the septic tanks and affect the way they break down that organic matter in the septic tank. A septic tank is actually quite efficient at processing a fair amount of salt a fair amount of nitrogen, a fair amount of phosphorus. But for the natural ecosystems, you can reach a threshold over which things become problematic. So better just to keep it really low, and be very careful of the products that you're using in your home. So just ending off then, before I have a quick word on next steps, I think we could be looking at, I look at Scarborough as an ecosystem. We are all part of that ecosystem. Everything that we do, whether we're sitting up on Hilltop Road, down below, closer to the sea, everything that you do in your home is having an effect on the Scarborough ecosystem, and we need to be very aware of that. Those orange arrows are showing how everything kind of exiting our ecosystem of Scarborough is entering the natural environment, and that is going straight out to sea. So we need to be very aware, as we would be very careful about what we put into our bodies, we need to be very careful about what we put into our environment. And also, I know, a lot of people are pumping out their conservancy tanks and their septic tanks, and that's important. But essentially what we're doing is that we're transporting our waste downstream elsewhere. It's ending up at Komaki, and other wastewater treatment works, which we know in the city are really battling. So ideally we would be able to deal with our waste within Scarborough. So what can we do? I think it might be interesting to do a survey. It would be interesting to know who's using a septic tank, using a conservancy tank, etc., just to gauge what we have in the village. We need to encourage everyone to understand their wastewater system and to fix it if it's not working properly, and to understand how to manage the system, that it's a biological system. We need to manage it like that. I do think that we need to encourage those with guest houses and B&B owners where there's a huge influx of people who don't necessarily understand or have the time to understand how a septic tank works. I think those guest houses with that massive influx of people should possibly be encouraged to install package plants, which we saw certainly with Andre's example work very well. We should encourage those who can afford it to install package plants, because those package plants essentially are making sure that we're dealing with our waste within Scarborough instead of exporting it somewhere else. We do need to boost the City of Cape Town data with our own data and sample more regularly, or sample regularly, at least annually, in Scarborough, and also at more locations, and then include the boreholes that we've sampled before. And it would be interesting to see what's coming into Scarborough versus what's coming in higher up in the catchment. So we'd like to have a few more locations and spread out the data collection a bit. And then lastly, and it's a project that I've always had in mind, which would be really, I think, quite useful for us to know where all the surface streams are and the springs in Scarborough. So where is the water flowing? Where are the problems? We could be sampling more streams in Scarborough and find out exactly where the problems are coming from, and so that we can understand those trends a little bit more clearly. So the task team has is motivated to go out and sample more sites and come back with more information. So watch the space. Thanks.
Great, thanks, Kate. Very thorough, excellent review of the issues here. Hugely helpful. Can I ask, are there questions or comments from anybody?
May I ask a question? Sorry.
Go for it.
Sorry,
yeah.
I can't put on my camera, so I'm sorry. I know it's a bit creepy to just have a voice hiding, but anyway.
We know who you are.
Yeah, exactly. I seem to be obsessed with E. coli. So the first question I want to know is, looking at your graphs, there have been a few times when actually our water has gone over the limits. And does anybody know, have there been reports of anybody getting sick from swimming at Scarborough?
Yeah, I mean, I don't know, maybe someone else can come in, but I've never encountered anyone being sick from a stomach, I've lost the word.
Like a E. coli type.
Yeah.
Or even stomach bug.
Yeah. So what I have heard of is people getting rashes from the water.
Oh,
But
wow,
I mean,
okay.
I would say a handful, 5 maybe in 20 years. And the rash wouldn't, well, I doubt it would link to E. coli or nitrates or phosphates. But yeah, maybe something else in the water that someone is allergic to. But yeah, it hasn't been a common thing in my experience, people getting sick.
Yeah, I also haven't heard.
I don't know if
And
anyone
then-
else has.
Yeah,
heard.
does anybody? And then may I be cheeky and ask a second question, which might just show my ignorance. So E. coli live in a warm body, but then so like how long do they last in the water? And what happens? They just become inert, and can they kind of resuscitate themselves when they when you swallow one? Because like a virus, obviously it breaks down with UV exposure and stuff. Does it? Do you know? I'm sorry, I know it's a bit unfair to ask this question, and maybe it's a stupid question, but I was just wondering, like, how long does that?
I normally look at larger critters, but I think, I mean, as far as I understand, they're viable, yeah, out of our bodies. Dave,
Yeah,
maybe you can.
Yeah. So I think, okay, so the whole point is 99.999% of the E. coli actually won't give you diseases. It's just a marker of how much contamination, fecal contamination there is in the water. But those few strains which will actually, there are some strains, there are 3 or 4 strains which will actually make you sick. People do get sick from these E. coli strands. They survive, I think, about in the range of days. And the thing is that they can't reproduce anywhere except in a warm-bodied digestive system. So, that's why they use it as a marker, because other bacteria can increase in number, decrease in number outside the body of a animal. So your sampling becomes somewhat difficult. Yeah.
Okay, great. Thank you. Thanks, Kate. It's a really interesting talk, and so nice to see that information. Thank you. And thanks to the organizers.
Thanks, Pauline. Any other questions or comments? While we wait for that, I can just share, I mean, my son swam in one of the rivers recently and came out with a rash. It was that bottom river. And we weren't sure if it was, cause and effect related to that, but there was that rash, and we have stopped swimming in there since. But what the cause of that is unclear. Tim, I see you raised your hand. Tim. You need to unmute yourself. Tim, you're still on mute, Tim. There we go.
There we go.
Sorry, my apologies. I think I told you I was a bit IT disadvantaged.
Okay.
Thank you very much, Kate, and everybody else who's making a huge contribution to an important matter. I just need to know when I don't know whether it's Kate or whoever can help us just get a measure of the problem. We have 2 or 3 little inlets, if you like, at the beach level, 1 or 2 are bigger. When can we do the testing? Is there a plan to do that? Because once we've established the problem, then John and I can start working on a plan.
Yeah, so the sampling we want to do at the moment is, we plan to extend it to misties as well, to at least, I think, 2 of the little streams that come through misties. I think the one, I had a brief look at the map that I think John put together, or was it you, Tim? And the one is right on the edge and possibly doesn't, pick up much from misties. So maybe the other 2, and it seemed to me the other 2 were more kind of central to Misty Cliff. So ideally, because the city doesn't sample there at all. So it would be great to add that.
The city doesn't what?
Doesn't sample in Misty Cliffs.
What?
Yeah.
Okay.
There's nothing there.
Okay. We small.
So it'd be good to add that to our regular sampling, just see the.
Okay. So can I report back my my sort of partner on the committee, John, when we could have some tests done? Have you spoken to John about that? Because that's effectively the next practical thing that we need to do.
Yeah. I think it's breaking up, but you're asking when?
I'm asking, who should I speak to in order to arrange these tests to be done in 3 or 4 streams?
It'll be part of our planned testing and collecting of samples. So we'll be in touch with you.
Okay. Okay.
Yeah.
Okay. Thank you very much. Just my last observation, guys, is that the people have the most appalling habits in terms of preventing, and I think there's so much we can do that are basics to prevent the spread of E. coli. My wife and I have the advantage of having grown up in the Karoo on farms, so we're not specialists by any manner of means. But there's some basics that are violated every day, 24/7. And there's so much we can do just at the preventative level that will make a huge difference.
Yeah, and too many people just think that they're flushing, they flush the toilet and it goes somewhere else. Yeah. Goes away. But it doesn't. I think we need to be looking at the whole thing as being a system, and it's just in our homes, on our urban. That's an ecosystem, but that is part of a bigger ecosystem, and everything's ending up in the sea. So we need to be very conscious.
Anyway, thanks for your support, guys.
Okay.
And thanks, Kate. Any other questions for Kate?
Sorry, you got me as I was engaged.
Put him on mute quickly.
I'm just looking at the chat as well. Lee was saying that they used to drink the water from schisters near the bridge and no symptoms. So that was in 2007.
Just a question from my side, Kate. The data that the City of Cape Town is pulling together, is it pretty frequent and very reliable data? You're confident of the quality of that data?
I'm pretty confident in their data. Yeah. It goes to their scientific services branch. And my dealings with them have always been that the data are reliable.
And in your advice, looking at those few times when the water is out of into the danger zone, it's not that often, but there are times when it isn't that area. Would it be useful to have some kind of notification or signage? I mean, one doesn't want to be alarmist in any way, but you do see kind of youngsters swimming in there occasionally. What's your thinking on that?
Yeah, I don't think it's too necessary. I think we've got enough information out there already, or enough signage already, and I think people must make their own decisions. I don't think it's dangerous, so. I don't think we need to put anything up. The City of Cape Town have a program called the Water Quality Improvement Program, the WQIP, and it's a recent thing. And I think it links to this committee that's been put together of very good minds when it comes to water quality, and that they're actually identifying parts of the city that need to be focused on to improve water quality, and the southern cluster, or whatever they call it, is part of that. So I'm quite interested to see what's going to come out of that, what their approach is going to be. Unfortunately, the southern cluster is a combination of all the streams in the south, sort of far south. That includes the Bokramspruit, which I know does have a lot of problems. Bokramspruit receives everything that's coming out of the Wildevlei wastewater treatment works. So I don't know whether schist is it's definitely not as problematic as the Bokramspruit, but I think if it brings cities' attention to us, I think that's good. So we'll see what comes out of that.
Great. Thanks, Kate. Any other comments or questions? So in terms of the way, yes, sorry, Dave, go for it.
No, Kate, I just wanted to say that that's amazing. It's amazing having a local expert deal with a problem like this. It's absolutely amazing. And I mean, the one take-home message out of here is measuring is always important, because without measuring, people naturally are anxious about the thing. So the first and the most important step is to measure. And one of the easiest things is just that wouldn't cost any money is to, like on a yearly or 6 monthly basis, just review the City of Cape Town's data, because it's there, that seems like a good thing. And then the other thing is just to get a bit more resolution of what's happening, as you said, by just having different sites to say, well, this is coming from, say, Red Hill or the farms there, and this is coming from Scarborough, or play with sampling in the pound thing, sample above where the beach toilets are and below. And by the way, because phosphorus is high, there definitely is something happening, because I wouldn't expect phosphorus to be high just from the beach toilets. I'd expect nitrogen and E. coli to be high. But the fact that phosphorus is also high is that those high samples are not just the toilet. Sorry, thanks a lot.
Exactly, and it's going to be interesting to see, because I mean, I know, certainly at forages, they've made such a huge change in terms of how the waste is treated there. It'll be interesting to see what effect that does have, because obviously the restaurants are having quite a big effect on water quality. I mean, inevitably, just in terms of volume.
Hi, can I have a word
Hi,
for
David.
a second? It's David. Yeah, David from Drain Clean 20.
Hi.
For me on the ground, because we've obviously been working very closely with the communities, with SEG and the likes of Kate and Andre and Kelson. So we've been actually doing the work in the village. So from my side, there's been a lot more call outs from the village community. So we have been servicing and inspecting a lot of tanks over the last few weeks. So I definitely think that this campaign is creating awareness, and people are definitely calling us out. I mean, the trucks, I know they're almost every day or second day doing some form of work. We obviously audit all the tanks and that stuff. There's no charge from that. I live in Komiki, so I'm happily out there quite often. So there's definitely a movement in the right direction there. Just regards with the restaurants, all three of the main restaurants are now on the program. Camel Rock, Whole Earth Cafe, and as well as the Hub. Microbes are being used. Fat traps have been installed and are being installed. And they're definitely looking at the way they're managing their effluent. So that's a positive. We're also tracking all the waste that we're taking out of Scarborough at the moment, from the amount of literages, etc. I can report back to you the majority of the septic tanks are between 2,000 and 3,000 litres. Some of them are too small for the houses. Obviously, houses have been renovated, the bigger houses have been built. I had a call from a gentleman in the front of Scarborough a few weeks ago. He's got a 5,000 litres conservancy tank in a new build that's been installed. He's got 8 to 10 people in the home on the weekends, but he's having to get that pumped out every 2 months now. So even on that level, that's too small for what they need to be doing. There's 621 homes in Scarborough. So, even if there were just to service every tank would take 2 years if you're doing 1 a day or 2 a day. So there are issues with the amount of, the volumes of going through. And obviously, as you've touched on, obviously the weekends, there's peaks of people coming in. So I think there's quite a lot of effort being putting down there. With regard to the microbes, we're getting a lot of inquiries around microbes, and microbes are available at Camel Rock as well as the Hub and the Whole Earth Cafe. The recommendation from us is to do a full extraction of your tank, do a full audit of it if there are issues, and then redose again, as Kate suggested, and start the whole process again if there are issues in that space. But there's definitely a movement in that direction. So that's very positive. We are directing them to the stores in the community to get the microbes. On the note of the use of chemicals at source, we're working with a colleague of mine, Liesl James, and she's put together a range of biodegradable products, which I'm going to pan some samples into the village in next week, and you guys can have a look at them. And they're all working with bacteria and microbes and carry on working down the line. So just from my side, I started getting involved like 12 months ago, actually with Ivan, and that's where this all started. And there's definitely a movement in the right direction from the community, wanting to fix things up. So, you know, it is moving in the right direction.
Great. Thanks, David. I've certainly made use of your services or those things that you're selling since that last presentation. Encourage others to do the same.
Okay.
So thanks very much indeed for that.
Yeah, and just on another note, obviously, again, this is more for the community. I'm very supportive of SEG and with Kelson. So we've also I've suggested, or our company suggested, that anybody that joins SEG in the membership, you know, does the annual membership, will get discounts on all the work we do, and 10% on what we do on any of their tanks, etc. Again, I'm just trying to encourage more people to join SEG. So if they can assist the community, you know, benefit everybody.
Wonderful. Thanks, David.
Yeah. Sure. Pleasure.
Kate, any last questions? I know it's now 7 o'clock, or just past 7, actually 10 past 7. So perhaps time to wrap up. Any burning questions or comments from anybody else? See, Andre, put your camera on. No, not a question there. Because if not, firstly, I want to say, well, thanks, Kate, for sharing your expertise. And we're hugely lucky to have people like you in the village, to do the work that you're doing and to share your expertise. But of course, thanks also to Kelson, who's been the key driver behind all of these issues and who set this call up again this evening. I don't know, Kelson, if you're there, I can see your iPhones here. But just to say, in terms of the way forward, we will make this recording available, and hopefully also, Kate, your slides, perhaps separately as well. You know, they'll be part of the package, but if we can see the slides separately, that would be great. But a huge shout out, Kelson, for driving this, and I'll echo David's call to get more members to become SEG supporters. So thanks, Kelson, for driving this. Thanks, Kate, for sharing your expertise, and thanks everybody for the questions. So unless there's any more, I think we can call it quits.
Thanks, everyone.
Have a good evening, everybody. All the best.
Cheers. Bye.
Ciao. Bye-bye.